Welcome to Circuits and Devices Lab. In today's video, we are going to learn how the experiment number 4, common base input-output characteristic, can be performed using virtual lab. Common base means base emitter of the BJT, that is bipolar junction transistor, is connected common to both input and output of the circuit. We are going to learn input and output characteristics of common base BJT using virtual lab. So for that we have to go to the Google and write virtual lab in the search bar and then select the electronics and communication branch. Then go to the basic electronics lab as I have shown in the previous video. Do the same procedure and select the basic electronics lab to perform the common base input-output characteristics. So select that. It will be shown the introduction part of virtual lab in this window. In that, select list of experiments. So in list of experiments, you have to select the BJT common base characteristics. So click to that. So this is your theory part of BJT common base characteristics, which covers the structure of BJT, operation of BJT and characteristics of common base BJT in this page. And make a read of this and then go to top and then click procedure tab. So procedure tab shows the step-by-step procedure to perform the experiment of input characteristics of BJT and then output characteristics of BJT common base. So read it once and then now we are going to start to perform our experiment by clicking this simulation button. So in simulation page, first we have to perform your input characteristics of BJT. For that, click this first button. So once you select this first button, will be shown the BJT common base input characteristics. So this is your circuit diagram which shows the input characteristics of BJT. So this is your bipolar junction transistor, base terminal, emitter terminal and collector terminal. So in the circuit, base is connected common to both input circuit and output circuit. So this is your ammeter which shows the current value of emitter IE, and this is your voltmeter, shows the voltage value of base emitter VBE, and this is your ammeter which shows the current IC, and this voltmeter which shows the voltage across collector base, which is VCB. Now we can also read the instructions to be followed to perform the experiment in this window. So first step, we have to set the rheostat RH1 and RH2 to 1 volt. So this is your rheostat RH1 and this is RH2. We have to set these two values to 1 ohm by varying this slider. So now RH is set to 1 ohm and then next is set RH2 to 1 ohm by varying this slider. Now the values are 1 ohm in RH1 and RH2. Next step, set the collector base voltage to 1 volt. So VCB should be set to 1 volt by adjusting the rheostat RH2. So now already the value of VCB is 1 volt. So keep it as it is as a constant value. Next, note the readings of emitter current IE in milliampere. So this can be done by varying the base emitter voltage VBE by adjusting the rheostat RH1. Now we have to vary the RH1 and note down the readings of VBE and IE. So the readings are shown in this ammeter and voltmeters. We have to add these readings in the experimental table by clicking add to table button. Now the values are noted in the experimental table. Now vary the rheostat 1 and then select the add to table button. Now the readings are noted. Do the same procedure for 10 readings approximately. So vary the RH1 so that VBE and IE also vary, and note all these values by clicking add to table button. So take up to 10 readings and note all the readings in the experimental table by clicking add to button. Now all the readings are noted in the table. Now you have to plot all these readings in the graph. For that, click plot button. So once you click, it will be shown a graph with the x-axis base emitter voltage and y-axis emitter current. Now this is your input characteristics of common base BJT. Next we have to do the output characteristics. So go back and click the BJT output characteristics button. So this is your BJT output characteristics window. So here you have to do the same procedure. So first we have to set the RH1 to 1 ohm and RH2 to 1 ohm. First step. So completing the first step, we have set the values to 1 ohm, RH1 and RH2. The second step, we have to set the emitter current IE to 1 milliampere by adjusting the rheostat RH1. Now vary the rheostat RH1 so that your IE value should be 1 milliampere. So you can use the minute variations also. Now the value is 1 milliampere. So next, vary the VCB, that is collector base is varied by adjusting the rheostat RH2. So you have to vary the VCB by adjusting the RH2. So vary this value. The values is noted in the reading, voltmeter readings. So thus the readings of collector current, that is IC, also gets varied. So these readings should be noted in the experimental table by clicking add to table button. Now the emitter current is kept constant 1 milliampere and base collector voltage and collector current are noted in the experimental table. Now we have to vary the RH2. So vary the RH2, keep RH1 as constant and RH2 is varied and click add to table button. Next vary the RH2 value, click add to button. Do the same thing for approximately 10 readings. So you can see all the voltmeter and ammeters are also showing the values and all the readings are noted in the experimental table by clicking the add to table button. So now the 10 readings are noted in the experimental table. Next step, you have to plot all these readings in the graph. So for that, click the plot button. So this is your graph which shows the base collector voltage in the x-axis and collector current in the y-axis. This is your output characteristics of common base BJT. Thanks for watching.